seasons and Earth's orbit. This is a big topic. There are questions on this every single test, so make sure you're on top of it. So what this is showing is Earth's orbit around the sun, not to scale by any means, but it basically to go from C, all from D to A to B back to C takes 1 year. So notice here, the Earth's axis is tilted. We're going to call the North Pole tilted like to the left in this case, okay? And it's always tilted the same direction. That tilt doesn't change. This diagram here shows a different view of the same thing, but basically the tilt now is this way. So don't always think left or right. Just think about, is the North Pole tilted towards the sun or away from the sun? Towards the sun, away from the sun. That is going to be essential for this. So first thing I want to point out is if this is Earth's orbital plane here, Earth's axis is tilted. It's not straight up and down. And that tilt is 23.5 degrees of, that's what the angle is. That's important to know, 23.5 degrees. And that tilt of the axis affects the angle that the sun hits at any location. Okay, that's important. This is kind of shown here. So this is like, let's say they take sunlight and make it into like a flashlight beam here. So here's directly overhead, a 90-degree angle. Here it's 66.5, and here that angle is 43. The key thing here, it may not be that obvious on this picture, but it is true. Here, that light is more concentrated here. It's all in one area. The lower the angle, the more spread out this area gets larger. Same amount of heat, larger area, larger area. Okay? This is called the angle of insolation. Insolation means sunlight. So the angle of insolation hidden in an area. Okay? And so this will have the most intense insolation because the angle is the highest. Directly overhead, the sun is strongest. That is important. This diagram here is zoomed in of the Earth, what the Earth looks like during the winter time. What I want to point out, the North Pole tilted away from the sun. Okay, winter, North Pole tilted away from the sun. That's important to know. I want to point out, when I say winter, I mean winter for us in the U.S. because it's a winter for us. It is summer for the people in the southern hemisphere. Okay, now let's point out why that is. So let's say you are in the southern hemisphere. Let's say you're right here in the southern hemisphere. Okay, notice where the sun is. The sun rays kind of directly overhead. So what would the intensity look like? Well, that would be like this. Okay, and that's as concentrated as the sun can get. So the sun's directly overhead. So that's why it's really warm for them. As opposed to where we are, let's say we're like this, we're up here. Well, if that's directly overhead, the sun is coming in at much more of an angle. This would be at noon. So it would be more like this. Okay, we're here. As a matter of fact, in the wintertime, the sun is even lower in the sky. At noon, it's like 24 degrees. So it's even lower angle. And it's that angle, the intensity of the sunlight, that causes these seasons. So that is important to know. Now, this diagram here shows orientation of summer. Now it changed. Now the sun's coming this way. So you have the North Pole tilted towards the sun. So, okay, that is key. Make sure that you know this, commit it to memory. So now we're this person in the southern hemisphere who had just had the sun directly overhead before, well, they may be about here now, and notice, well, that's overhead for them. The sun's lower in the sky, okay? So that'd be winter for them. And where we are, we would be something like this in New York, like this. Now notice, the sun's not directly overhead. The sun is never directly overhead in New York. It's never 90 degrees up. Make sure you know that. The highest it could get is 72 degrees above the horizon. But it is higher, therefore the sun is stronger, therefore it's summer. Important concept. Okay, now we'll go back to here. So in this diagram here, showing North Pole tilted away from the sun, it's winter. North Pole tilted towards the sun, it is summer for us in the state of New York. And then here, just a different diagram, kind of looking at it from a different perspective. In this case, the North Pole tilted towards the sun, summer, and then this would be winter as the North Pole's tilted away. What I also want to point out, look, you're at the North Pole right here, and Earth is rotating once every day. Do you ever rotate into this dark nighttime? You don't, okay? So if you're very close to the North Pole in the Arctic Circle in the summertime, that's where they have 24 hours of sunlight. All right, this is totally cool. And at that same time, if you're down in the South Pole, you have 24 hours of darkness. Reverse, when it's winter time for us, look, they never rotate into the light side, so they have 24 hours of darkness. Sad face, that would stink. And then the South Pole has 24 hours of light then. So that's totally cool. I do want to say this. Be careful, because seasons are not about how close we are to the sun. Summer is not when we're closest to the sun. This is summer. Look, the axis tilted towards the sun. We are actually 5 million miles in this 5 million miles, kilometers further away in the summer. We're further away in the summer. We're closer in the winter, but it's all about the tilt, because it's all about the angle of insolation. I can't get that into your head enough. All right, so summer and winter, all again based on the axis. Know it.